Welcome everybody to Gulf Coast State College. We are so pleased to see such a good turnout. Fantastic. We have some great speakers here today. These are international experts on alternative energy. If anybody knows about the German model, one of the best, if not the best, industrialized alternative energy program in the world. And their economy, as you all probably know, is the strongest right now in all of Europe and is the leader in Europe and has helped us in many ways keep Europe going as strong as it can go. My name is Jeff Stevenson. I'm the Chief Economic Development Officer here at Gulf Coast State College. I know what I do here. And so we've got a great panel here, and we're going to have a community moderator, and Mr. Al McCambry, I'm going to introduce him in a second, but we're trying to really connect with the community. I'm going to try to get an understanding. Who here is an engineer? Any engineers here? Wow. Looks like most people are engineers. Okay. Any architects? Any architects? Yes, sir? Okay. Okay, you know. Let me see. I talked to some people. This gentleman from Indiana, you're on economic development group. You're trying to look for a company that's into kind of alternative energy. We have probably some Encore people here. Where's Jim? Encore people here. I saw 4 or 5 of them. Great group here, some students. Are you 3 students at the college here? Yes? Thank you for coming. Okay, so we have some great speakers. Al McCambry has been the chairman of the board of the Beach Chamber of Commerce, the Bay County Chamber of Commerce. He's now the chairman of the Military Affairs Committee. He has a tremendous business background. And so we're going to have him, and I'm going to help him moderate this day today. But would you please welcome Mr. Al McCambry. Thank you.
First of all, I'd like to thank Dr. Curley and Dr. Stevenson for allowing me to be able to participate in what I believe is an important conversation, the next generation of energy and sustainable design, a concept that I also believe fits very well with the mission of the ATC, one that is too often taken for granted and one that just does not receive the just due that it deserves. I have had the privilege of speaking informally with our esteemed panelists over dinner the other night, and I can tell you, you are indeed in for a treat. Not only are they well respected within their respective fields, but as you will soon discern, they bring a great passion for what they're going to be speaking about. And if there are any non-engineering folks out there in the room, you will be as pleased as I was that they are able to break it down for us mere mortals here, and like myself. When you guys spoke the other day, I probably got about 60% of what you said. After today, I hope to get a 80%. I know that's only a B, but for a non-technical person, that's pretty good from a finance degree, so that's my goal. Now I would like to introduce Medet Amesky, who is really responsible for getting this program off the ground. And before I do that, it would be remiss of me not to also thank the staff at Gulf Coast State College to help to coordinate and bring this event to place. Please give them a round of applause. Now, Mr. Amesky graduated from Alexandria University, Faculty of Fine Arts with a Bachelor of Science in Architecture in 1969 in Alexandria, Egypt. He graduated from the Pratt Institute with the Master of Science in Urban Design in 1975, New York City. He's a business owner, designed art studio right here in Panama City, Florida since 1990. His firm was established to provide quality services, integrity, and professionalism in urban design and architecture. He has been awarded many certificates of appreciation for outstanding accomplishments and contributions to Panama City Downtown Improvement Board and many outstanding State of Florida honor awards for new construction. He is the co-founder and the president of the Islamic Understanding Institute, a nonprofit organization founded in 2009 to heighten the appreciation and understanding of Islam and all things Islamic for the citizens of Bay County and the Panhandle area. Please help me greet Mr. Medet Amesky.
Thank you very much. I would like to thank a lot Gulf Coast Community State College for the work which they done to get this program really on its feet. I would like to welcome all of you today. Talk Next Generation of Energy and Sustainable Design. It is sponsored by Islamic. Okay. Antonio, can you put this? Yes.
I'm sorry.
Yeah. Okay. You're going to, how you do that? Move that, okay. Okay, it is actually sponsored by Islamic Understanding Institute, IUI, and I am the president, Medhat El-Meski. Okay, Islamic Understanding Institute actually is non-profit organization established in 2009, is serving the citizens of Bay County and the Panhandle area. Okay. Actually, as we see here in the center, we see that actually that we have the highlight Islamic, the Islamic Understanding Institute. It highlights Islam universal values and all-encompassing principles which are relevant to our daily life through seminar workshops, through educational programs, and through social services programs such as Abyssinia Free Clinic, which we are established 2 years ago, and we serve almost 1,000 non-insured persons in Panama City. And you're welcome to know the address and the telephone number, and you can come. It's totally free. We have almost 18 doctors serving that. Actually, also through publication, which we are working on it. Now, as you see here, collaborating across borders, IUI actually, as you see here, sustainable energy, shared vision and the common goals. It is, you may asking yourself, what is the connection between IUI and sustainable energy? Well, you today talk highlights sustainable energy as a goal that is shared not only at IUI, but also locally in a fine institution like Gulf Coast State College, and nationally in the President Obama vision for the USA, as we understand that, and internationally in the continuing in country where hard work is being done to implement this vision. And I would like to thank Dr. Fish that he is coming here from far away from Germany to share with us this vision and his expertise. So thank you very much, Dr. Fish. And by that, I would like to end my small talk. That is, you're welcome to Islamic Understanding Institute anytime. It's actually, it's a Lincoln Center. We have brochure here, and they give you the mission, the goals, what actually our vision, and is non-affiliated with no other organization. This organization is mainly created here in Panama City, in Panhandle, to serve the citizen. We've been here for 22 years myself, 41 years in the United States, and we are actually American citizens, and we're sharing our civilization and also the cooperation between our vision and our society here. Thank you very much, and enjoy the talk. Thank you.
Thank you. I would next like to introduce Mr. Antonio Adesi. Mr. Adesi's professional and teaching philosophy has always been to combine research on an interdisciplinary level with real-world problems from an urban scale, such as transit, sustainability, revitalization, and the preservation of the historical built environment to agricultural and product design. His designs in support of the local communities and engaged the community in seminars, charities, and exhibitions so that the professional and academic activities could meet both the private and public sector needs. Another branch of his research is the design process in the evolving digital media technologies. Mr. Adesi created the first certificate programs in the state of Florida for alternative energies, sustainable design, and green building construction technologies and digital manufacturing. Ladies and gentlemen, Mr. Antonio Adesi.
I really want to thank you, all of you, for being here. It's very exciting to see such a large audience. As you know, the college, we were community college, we went state. It's not that we forgot our mission. We are here to support our community, the growth and the creation of workforce here locally. And so that's why we love to be the home of first times in the state. That's why we push so hard to be always on the cutting edge. That's why we created programs that nobody else had before. So that's why in 2009 we created the first program in alternative energies. Then we developed sustainable design and the green building technologies, and the brand new one in digital manufacturing. This is all to support the future workforce, to be able to train the workers that you're going to be able to hire in the near future. As a commitment to that, I'm sure a lot of you are familiar with our ATC, that is the new Advanced Technology Building. And that center, it's a $35 million statement that we are here to support the local economy, to support innovation and job creation. So thank you for being here, and we're very excited to learn about what Germany is doing. Thank you.
And one other housekeeping notice that I forgot to mention, please put your phones on vibrate, just in case so when the speakers are up speaking, your phones aren't ringing in the background. At that point, I'd like to introduce Dr. Ali Shaban. Dr. Ali Shaban, ARA Energy Research Development Technology and Engineering Initiative Director, that's a mouthful, is a mechanical engineer with over 35 years of project management and over 21 years of program management experience. Since joining the ARA in 1986, Dr. Shaban has worked on a number of energy-related defense DoD projects to reduce fuel consumption and technology footprint on deployed bases, sorry. He and his team are developing sustainable technologies using renewable energy and thermal storage concepts to reduce energy demands on the building and deployed shelters. Dr. Shaban received his Bachelor of Science from the University of Alexandria in Egypt and a PhD from North Carolina State, Raleigh, North Carolina. Please help me introduce Dr. Shaban.
Good afternoon. I'm really happy to be part of this event. I'm looking forward to hear Professor Fish talk about the German plan to develop the Energy Plus concept and the milestone that they have already met and the milestone that they're going to have to meet to complete the development of the Energy Plus plan. Actually, we have a similar concept. It's not as ambitious as the German plan. We call it the net zero energy concept. And from the name of it, we're looking for installations and buildings to produce as much energy as it uses. Of course, the German plan is produce more energy than the facility uses. Okay.
For you to implement any of the two plans, you have to have a set of efficient technologies, either the energy generation technologies or energy user technologies. And if we have those sets of technologies, then hopefully we can reduce to zero the external fuel and energy requirements for any installations. We know that there is a limitation of using thermal insulation, using renewable energy, and these limitations, either economical limitations, location in the wind power case, and the availability of surface area in the photovoltaics application. After we are achieving the limitations for these technologies, then further reduction will require really better tools to design energy systems and more efficient technologies. Of course, we divide the energy efficient technologies into two: the sustainable energy production technologies like power generation, whether it's from solar, from wind, or from the wave power, or from biofuels, or the energy demand reduction technology, which is really the energy users like air conditioning, refrigeration, these kind of technologies. There are a lot of opportunities for renewable energy. If we concentrate on the solar opportunity for now, you can see how tremendous the solar incident on Earth. As a matter of fact, they say that the solar incident on Earth for one day equals the entire human energy use in 1 year. So if we have better technologies in harnessing the solar radiation, then we can produce more solar electricity. If we make a comparison between Germany and USA, you will find that in population, United States almost 4 times of Germany. In land area, is almost 28 times. Germany is almost as big as Montana. It's smaller actually than Montana. And in GDP, again, United States is almost 5 times of the German GDP. If we look at the energy incident on the United States, it ranges between 1,200 and 2,500 kilowatt hour per meter square per year. If you look at Germany, it's between 1,000 and 1,400. Now, if Germany has the guts to declare that Energy Plus plan is the national goal of the country, then I think we need to have the guts to declare at least the net zero plan as our national goal in this country. In ARA, in our Smart Energy Group, and SMART stands for the usual renewable and sustainable technologies. We work on few technologies, developing few technologies, efficient technologies, and the energy consumers and energy production technologies. I'm going to just give a few of them just for sake of time. One of the technology we finished is this SWES design. SWES stands for Solar Wind Energy System. It's a software package. It can help us in designing a new base. Actually, it was funded by the Air Force to design new deployed bases, but can be applied on fixed bases too, or subdivision or compound or any commercial or industrial building. It can help us in designing the new buildings or facilities to achieve maximum renewable energy output. It has a 3D interface, and it has an extensive database for solar incident and wind energy worldwide. It interfaces with different file formats, so it can get the layout and the information about buildings in a base, for example, and especially interface with the shape files that Air Force uses. It has multiple shelter and building design in the database, and any building design can be added easily to that software. It does the life cycle analysis, and it can tell you what the payback period is for the technology. And it has a weather forecast module to be able to give you the forecasted weather for the future 5 days or so. So the energy manager can decide which energy source he will be used in the coming days to reduce his or increase his energy efficiency. Of course, for existing installations, the package can advise us on where to apply the solar photovoltaics or the wind mills to achieve maximum energy output from those technologies. The second project we worked on is a hybrid ECU. This includes a thermal storage unit in it. And the first design we made, we achieved between 26 to 37% reduction in the compressor runtime. We redesigned the unit and we're testing it right now. We are hoping to achieve 50 to 60% reduction in the compressor runtime. Thermal storage in building, and this is to increase the building walls thermal inertia. It's like old days when the ancient Egyptians built their homes and worship buildings. They built it with thick walls to maintain the temperature steady inside the building. So we can do that with the phase change material. If we integrate that in the building walls. There are two products available. They are not commercial yet, but you can buy them from the companies. One of the thermal core, which is a sheetrock impregnated with a microencapsulated PCM. And the other product is the Thermomats, which is installed behind the sheetrock. It's a mat with pouches that filled with the PCM. If you look at the curve on the right, this is the result of a test of two identical buildings. One of them without the PCM in the walls, and the second one with the PCM. And you can see in the first one, the red, that the air conditioning unit could not meet the cooling demands on the building. And it worked solid from 2:30 to 7:15 p.m. The building with the PCM in the walls, you can see that the heat pump met the demand for the building, and that's why it's cycled. The calculated energy savings for this application is between 18 and 30%. We tested the same material on what we call the doghouse test. We have two small buildings look like a doghouse. One of them is again equipped with the PCM and the other without. The PCM unit was on the walls, as you can see in the picture, and under the roof of that doghouse. And you can see on the graph, you can see the daily the outside temperature. That day was apparently a little cloudy, and the temperature reached almost 85 degrees that day. The unit that without the PCM, the attic temperature and the interior temperature just followed the same behavior, while the one with the PCM just almost as steady over the 24 hours period. It ranges between 71.5 and 73 degrees inside that doghouse. Of course, the PCM product potentials are huge. You can see them actually, they use them in the pizza boxes. When you have delivery of pizza, that box they have, it has PCM in it, so it can keep the temperature at the right temperature to reach you hot. It can be applied or used in the tiles and floor covers, in furniture, and the wall, I mentioned it, in paint, and in mechanical applications like heat exchangers. We have another project which is a multi-fuel electric generator, and this can take, we developed a fuel processor that can take any kind of gaseous or liquid fuel and convert that to hydrogen-rich syngas, and then the syngas can be fed into a fuel cell to power it, to produce clean energy. The 5 kilowatt we were working on, when we compared it to the new Army generator, the 5 kilowatt, we met all of the requirements for that generator. The targeted fuel efficiency is about 45% if we use high temp fuel cells, and 65% using the solid oxide fuel cell. One of the projects that we finished very successfully. I hope you guys seen that on TV yesterday in the news about AFCAC, and we displayed the efficient shelter technology. We were able to take a shelter, and you know, in deployed bases, each shelter has a 5-ton air conditioning unit, and this 5-ton unit runs 24/7 just to meet the cooling demands on the shelter. So we took the shelter, we had a fly put on it, and the fly, we put photovoltaics on it, a 10-pin photovoltaics, and we used better liner in the shelter, and we used a better door on it, and we were able to cool and heat 2 shelters with 1 heat pump. That's a huge reduction in fuel consumption on deployed base. If we calculate the reduction with the photovoltaics generation, we reduce the fuel consumption by 46, almost 47%. And if you know that the 70% of the power generated on the base is consumed in the air conditioning, this translates to a 33% reduction in fuel use on the base. Our next step is to model the shelter thermally and really design each layer to give me a maximum thermal resistance to the heating and cooling load. Thank you.
Thank you. The next speaker is going to be Dr. Aruf Arafa. Got a Bachelor of Science in Nuclear Engineering in Alexandria University, Egypt, 1967. A Master of Science in Automatic Control and Fluid Mechanics, Stuttgart University in Germany in 1975. Doctorate of Engineering in Building Physics, Solar Energy, Thermodynamics, Stuttgart University in Germany in 1982. Former Professor of Engineering at Cleveland State University, American University in Cairo, Director of Research and Development for 3D Printing, CEO of Energy Conscious Design and EGS Plan USA. Please help me introduce Dr. Aruf Arafa.
Thank you. I know that there are a lot of engineers here. I have to test your knowledge to prepare you for my friend Norbert Fish here. How many of you knows the difference between kilowatt hour is energy or power? Who is for energy? Raise your hand. Engineers. Who's for power? Raise your hand. It's 50-50. Okay. It's basically energy. But I hope this will be, we should teach our kids. Everyone knows what dollars for, money-wise, euro. This is a unit of energy that every child should know what's the unit of energy. We should teach our children. But I see also a youngster like me with gray hair. So I will say some about history. This is 1997. If you remember, this was the first. 1973 was the first energy crisis. Anyone remember that? And I was in Germany at that time, and if you remember, Norbert, there was restriction on driving cars in the weekend. It was allowed 1 week, and the other was prohibited. And you know how the Germans love freedom, love their cars. And if you cannot drive the car, this is the worst things that you can do for German citizens. The one with this light, you know who's that? That's Norbert Fish. We started working with solar energy, and that's me. Supposed to be. We started working with solar energy, and for 10 years I stayed in Germany. After that I left. Professor Fish continued 30 years in energy. As a matter of fact, about energy crisis, the Europeans were very mad at the Arab states. As Egyptian citizen, I grew in Egypt, and we are surrounded with all oil countries, but we did not have any oil. So I did not know what to do to defend, but as a matter of fact, my thinking was, it's an unfair distribution. The energy is so important. Why it's only located in some of these countries? Yet, now the solar energy is uniformly distributed everywhere in the world, under your hand. And it's not harmful. This is little more, but still, it's out in the atmosphere, it's equal uniform, okay? Next, I'll go to the next slide. I came here to the United States in 1982, and I started building a big house, energy efficient. And the concept that I was following was what I learned in Germany. I was actually the architect, the engineer, the builder, the laborer, everything. And I actually used the integrated design concept, utilizing the natural site, look at the site, what you have. I found in the panhandle here, you have underground water, the temperature is 55 degrees, believe it or not. At that time, 20 years ago, I don't know what it is now, but the average temperature over the year is 55 degrees. So I can use the underground water for preheating, pre-cooling in the building. Also, one of the things that I noticed that here, the way not to do it, distributing the heat. How you are heating or cooling the building make a big difference if you optimize the way you distribute the heat or the cooling in the building. Using the thermal math, optimal sizing of any buildings that I design, I make the sizes of the wall, some at the height, with the dimensions that are available. At the end, I don't have 10 dumpsters to waste my material, and my waste is minimal. Optimal insulation, I'll talk about that. Professor Fish will talk about that. And also to make the customer aware of what I'm doing. Next slide, I'll show you. This is the house I built, I designed actually, and this is me also jumping inside the house. This is indoor swimming pool in the house, 60 feet, approximately 7,000 square feet added to existing house. This house exists in West Bay. If you drive 388 west, south, Pearl Creek. This is the only big house you can see. I don't know who's the owner, and I don't think that the owner knows what he has here. But next slide, this shows you the roof is facing south, that it was prepared to put solar collector, passive solar gain. All these windows are for passive solar gain. The next slide, I'll show you. This, of course, at that time there was no AutoCAD. I put, if you look at all this piping around the swimming pool area, I put insulation under above the grade and put cover pipe, 3/4 cover pipe, header, and I planned on putting coaxial pipe, getting underground water 55 degrees and distributing this in the area of the pool, of course, for preheating, pre-cooling only, and avoiding the condensation or the dew point. All of this has to be done. Of course, I got in trouble doing that. This is a state of the art nowadays to use the floor heating, floor cooling. At that time, if any one of you here was here for that long, there was a Scotty, there was no Rose or Home Depot or any Scotty, only the warehouse and the Ace in Glen Burnie. The next slide. This is after 20 years, or this is 2000. Basically it was 2000, a house that's built. You can see this is the south facing, also the roof is prepared to put solar photovoltaic. The day sunlight, every corner in this house, the north or the south side gets daylight. The next slide. This is the inside of the house, show you this is the north side, and this is the south side. One is the north and one is the south side. At the day, during the day, you have enough light without using any energy. Next slide. Now, as you have seen, I have a background in nuclear engineering, background in energy, solar energy, everything to deal with engineering in any respect, but related to energy. And also I got like 15 different courses in mechanical engineering, electrical engineering, you name it. In my opinion, you can sail against the wind. You can actually pull with the sun, but you cannot go against this wave. And with this wave, this is what I mean, that's your wave and my wave. Solar energy was not the things that you can set at that time. Next slide. My knowledge in Islam is very little since the Messi here is Islam, but I have more knowledge, I think, in engineering. In Islam, I learned that 3 things that you cannot manipulate. Air, which is the cheapest, and you need air the most. You agree? You cannot. This is the things that you need to the last breath. And vegetation, water, and also energy. No one can manipulate that. And it has to be to all human beings. Next slide. This is what I would like to leave you with. If air is so precious, can you imagine if one of us came with his car here and left the car running? What's going to happen? Huh? No, you are not going to be, you're going to die. This is well known, this is fact, right? So, what do you think this is going? It's going to go to the moon? Huh? Do you know that the oil spills that happened in April 2010, the whole amount, United States consumed this in driving, 6 hours only. And when people were protesting, my opinion, how did you come to the beach to protest about oil drilling? Every one of us sitting on the beach. Oil drilling. And you know, it's basically what bothers me as engineer, and since there's a lot of engineers here, the fossil fuel, when you burn it, it's basically consists of carbon and four element or the molecule is one carbon, one atom carbon and four hydrogen. You burn it, the hydrogen splits the binding energy. You are using only the binding energy, and everything you are throwing it into the air. Every atom, every carbon atom take 4 oxygen atoms. I wish a young engineer can calculate. The universe is limited. You can calculate how many atoms and how long this will last. It's simple calculation in my opinion. But by all means, what you are doing to the air here is going to go to the moon? No. It's going to stay here in the atmosphere. We are in a big garage, whether you want or not. Big garage that we cannot afford to produce the air. Next slide. This is a house after 40 years now, 2013, that Professor Fish here came and we put the photovoltaic in our house. And I hope to leave you with this, that I hope everyone, before you push on the gas pedal, I know there is no alternative, but at least this is your will now, and I don't care whether the government support that or not. You use your dollar to save yourself before you will pay for a drop of air or oxygen. I will thank you and I'll let Professor Fish take over.
Thank you, Dr. Rafa. And as a non-engineering person, I can tell you I still do not know the difference between power and energy. But as a finance person, I can tell you I understand about dollars and currency. With 2 kids in college, I do not have enough of it. And what I do have, they take all the time. But power and energy, I don't understand yet.
One thing here, the United States, every person use 12,000 watt per person per year. In Europe, they use 6,000 watt is power. When you multiply, watt is actually energy per time, and you multiply it with 1 kilowatt hour, is energy per time times time is energy. Kilowatt hour is energy. This is what you pay for electricity. But in Europe, they use 6,000. Here we use 12,000 unit of power. In Europe, they use 6,000 per person. In the underdeveloped countries, developed countries, they use 200 watt per person. 200 watt is like basically maybe 2 light bulbs per year, per person per year. So your contribution for the pollution is 200 compared to 12,000. Okay? And I think, yes, somebody's asking. I think in the future, you know what's the PV paid for cleaning the oil spent. You can calculate what they paid divided by the number of gallons that they collected or they spent in the water. And this was the least pollution because at least you can actually collect as much as you can out of the water, separate the oil from the water. But what you put in the air, that's it. It does not come back.
Rest assured also after our keynote speaker finishes his address, there will be time for questions and answers at that particular point in time. So please write them down if you have some already, and as you hear our keynote speaker address the auditorium, please also write additional questions down that you may have. Now, our keynote speaker is Dr. Norbert Fish. He's a full professor and director of the Institute for Energy Design, Building Services and Solar Technology. He is also the Dean of Engineering at Technical University, Brunswick, CEO of EGS Plan, Stuttgart, CEO of Energy Design, Brunswick, CEO of Energy Design Asia, Stuttgart, and Shanghai. He got his bachelor's in engineering in 1974 from the University of Stuttgart in mechanical engineering, master's in 1976, University of Stuttgart, emphasis in engineering, energy technology, PhD in 1984, Faculty of Mechanical Engineering, University of Stuttgart, with a thesis of theoretical and experimental investigations of solar-assisted air heating systems. He has published over 100 papers in the areas of solar energy, rational use of energy, energy-efficient office and residential buildings. He is also a well-known author for numerous books related to the efficient use of energy. He has numerous awards: the German Award on Building Physics in 2003 for the comprehensive energy design of a smart green commercial building in Berlin. 2008, he won the German Solar Prize, the solar-assisted large-scale solar heating systems. He has actually won an award in 2012. I'm just going to call it the Energy Award because it is written in German and I can't say it. So without further ado, I will introduce Mr. Dr. Fish. Please come to the front.
I put on my mobile phone because looking for the time. I think I have 45 minutes, okay? Because you have good. And the mic, you want this one? The mic? Yeah, because you know, I know from the students it's very heavy to listen 1.5 hours, and now the modern students I'm very happy that you have not so much mobile phones on and working on it. But 50% of my nearly 200 and 300 students in front of me, 50% are only playing with these things, and I call them digital demens. Demens mean when you forget something, you know. And they all dimensions. How say dimensions? Okay. Dementia. Okay. So okay. First, I would like to continue with my friend Ralph Arafat said. Do you know how many kilograms of air you breathe every day? Because he said air, water, and things we human need. You know how many kilograms of air you every day eat? You eat or breathe? Of course, you breathe, but you know how much kilogram of air? Some of you know it? 1,000. 1,000 kilograms. Oh, yeah, oh, I'm sorry, kilogram. I'm coming from Europe, and you understand kilogram, I think, right? Most of you know most kilogram. So 50 kilogram. You know how many water you need per day, minimum?
1 gallon.
1 gallon is 4 liters, I think, right?
3.87.
No, it's 2 liters is enough, and half a gallon, and it's you can survive half a gallon. So it means 2 liters. 50 kilogram air, 2 liters of water. You know how much you have to eat? How much kilogram? Depends on what you eat, of course. I know. But in average.
1 kilogram.
Right. So 1 kilogram, 2 kilogram, 50 kilogram. So I would like to tell you, air is really important, especially the air inside of the spaces, of course. Okay, this was not my talk, by the way. I would like to speak about advanced sustainable buildings. And by the way, all buildings I will show you from point of the architects is our design, it's our engineering, and it's our child, let's say our child. And I would like to also mention that maybe compared between the United States and maybe Germany and Europe, none of my colleagues is only working on the university. I will never teach my students if I not build buildings, how I can teach how to build buildings, architecture or engineering when I'm not building things. The week, let's say I 2-3 days on the university, and the other 3 or 4 days, because I'm a workaholic, on the company. So this is my profession, is to stay in the praxis and to learn how to build. Otherwise, I could not read that in the book, by the way. So this I would like to mention, that all the projects you will see, it's our child. This we starting, as Ralph said, in the 70s with solar, and we starting with also your nice PCM, yeah. In the microcapsule PCM, we have done a lot of research, and in the last years I changed from the engineers more to the architecture, to the urban planning, because I see the more challenge in the city. The city is the challenge for the future, not the single house. So in the last 10 years I'm working more on, let's say, cities or on larger scale of buildings. And during all this way, 40 years now, we established a lot of companies around me. So now at the moment we are nearly, let's say we are nearly 70 to 80 engineers around Germany and Shanghai and in Dubai. And on the institute we are 30 scientists. So the reason I'm here, by the way, is that we created a EGS plant in the United States here in Panama City. So together with my very old friend, we would like to introduce solar systems in the practice. And the reason is, I think that the time is now there, because we had the revolution, and the revolution was that the Chinese have now producing the photovoltaic system 10 times, not 10%, 10 times less as it was maybe 5 years ago. When you asked me 5 years ago, have photovoltaic a chance compared to solar thermal, you make hot water, solar thermal, I will never say, oh yes, it had a chance. They have had no chance, because photovoltaic was so expensive in the past. And then it came this revolution in China. The Germans and all the other countries developed the machines, the production there, and now they re-import, and all the German the German companies are bankrupt, by the way, at the moment in the solar energy field. But this was happening for the customer. For the customer, what's happening now? I'll give you the message. At the moment, if you put one piece of photovoltaic on your roof, it's cheaper than the electricity buy on the grid. Maybe you're now not believe me, but we can go in detail if you like to know the real prices, because this is what we have done in the past, in the last, let's say, 10 years in Germany. So let's go very quick to this. This is a challenging trend. The challenge is, of course, 100,000 people per day. We have the challenge of the climate. We have the challenge of the cities, because 2050, 70% of the whole world population would like to live in a city. There's a calculation that at the moment there was an amount of cities. By 2050, we will have more cities as we have at the moment now. Could you believe that? You have to think on it. 2050, we have more cities in addition as we have cities now. Of course, this is not in the States, this is not in Germany. This is outside of our countries. But this we have to consider when we're thinking on energy conscious, let's say, goals. The cities is the challenge, not the building, but the city building. So another challenge is that the private mobility have just begun. Some people think that we have enough cars. Maybe you have here enough cars. Also, we have enough cars in Germany. But if you look on the whole world, that the mobility has just begun. Just begun. So my English is not so perfect, sorry. And also another challenge is, especially for maybe for the States, similar like for Germany, that we get older and older and older and older. By the way, you know what country have the lowest average age of people?
Central Africa.
No. You could not know it. Oman. 17 years. 17 years, the whole population of Oman. Because these people have 8 to 9 children, the families there in Oman. They're only 3.5 million, by the way. But also another country who have a lot of young generation is Saudi Arabia. Saudi Arabia is growing rapidly. Germany, we are similar, we are stable. So this is our problem. And I think you see also Germany as well as the States is, by the way, 22%. In 2050, the people are older than 65. In Germany, 1/3. Means every third person is older than 65. It's a challenge, or this is really a challenge for us in the future. And another challenge is this. But since you know the actual discussion about all the spreading of things like this one, okay? Another big challenge is, and this is I would like to speak about, is the challenge that in Germany 70% of the energy going in building and in transportation, 30% in industry, 30% in building and in transportation means we engineers, we are architects. We have 70% in our hand. The urban planner, the engineers, and they have 70% in our hand. This is what we're doing. We're designing mobility, we're designing transportation, we're designing cities and buildings. And only 30% in the industry. So this is our challenge, and another challenge is 50% of the worldwide materials consumption is construction. And another one is 60% of the waste materials is also linked to construction. Mr. Arafat told us he built nice houses without garbage, without waste, but this is the reality. 60% of the whole waste what we're producing comes from building construction. And so we have this, we have to think on. For water. So as I mentioned, we started in the 70s, and when we started in the 70s, we started. We started with small houses, like this one here. This is one of the first houses. Philips, a company who produces the lamps. We're working together with them. Oh yeah. And so now the top. I would not like to tell you the whole story because the whole story is maybe too boring. And the end of the story was that we built some energy autonomous houses, but this makes no sense. In countries like in USA or in Germany, Europe, we don't build houses who is self-sufficient. This makes no sense. But this we have done in these years, in the 90s, we built a lot of houses with self-sufficient, but self-sufficient is too expensive from the economy point of view. We have a grid, we have to feed in the grid, and so the last years we're thinking more on the smart grid technologies. All things are linked, the cars linked with the buildings and so on. So this I would like to speak about. So I think I speak a lot about this one. So this is the National Plan of Germany. What is the National Plan of Germany? The National Plan was 2010. Our Chancellor, Frau Merkel, she introduced it called the National Energy Plan. It was the first energy plan we had. And it was a plan to have real values, clear objectives, not only blah, 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 we could do this, and maybe we could do solar, and maybe we should have wind, blah, blah, blah. Huh? No, it is a clear objective was set. I will show you the figures. And this, I hope I translated right. Energiewende. Energiewende, if you go by a car in this direction and you make a U-turn, you go in the other direction. This is the word in German, Energie, energy. Wende means you make a U-turn. And this means that energy U-turn, 2011, came after the plan. And in this energy U-turn, one thing maybe you have heard, Germany switched off all nuclear power plants. Yeah? We have switched off, we had nearly 20, we switched off 8, nothing has happened. Nothing was happening. A little bit more gas generation plants are growing up, but in 2020 we will have all nuclear power plants off. There's enough time, and I think there will, from engineering point of view, no problem. No problem. And also this will be solved, I think, in the next 6-8 years. But what we need, of course, is what I mentioned here, is a cultural problem, or a cultural change. If we not take the people with us, we could not reach this Energiewende or this energy turnaround. We need the people. And the people have to follow these political decisions. So what was the real goal? The real goal was, this is the real values. So the decision was that every 10 years, this is, for example, the renewable energy will, from now on, we have 20%, by the way, 20% of the whole country is supplied by renewable. 20%. It's a huge amount. America at the moment is nearly by 6 to 8%. Totally, everything. Everything means traffic, industry, the whole energy consumption of the country. 20%, and in 2050 we will have 60%. This is the goal. And electricity consumption should be down from now, it's not so much, only 20% should be down. You see that here, Opala. Here. From here to here, 20% electricity only down. This is to have more efficient light. You have more efficient, what he told us about more efficient chillers, more efficient heat pumps and so on. But the reason that it's not so quick down is that look on your private home. We're installing. Everyone have a dryer, everyone have a fridge, and everyone have, I don't know, an old fridge, a new fridge, and a more old fridge. Everything is running and running. This is the same in Germany as maybe in Europe. Yeah? But this is the reason, and when I look in my private office, how many servers we have, how many computers now we have, how many screens we have. So this is the reason that electricity only goes slowly down. Yeah? This is the reason. But the primary energy goes more down because this is the dependent on transportation, more efficient cars, more efficient buildings. This is easier to come with electricity down. Because I believe, personally, we go to 100% electricity. This is the only energy who will survive from the transportation and the city. So I'm 100% sure we will have in the near future only electricity. But here in the States, I know you stick more or less on electricity. You have less oil in your private homes, not much gas. You put all the things on, I think, on electricity. But this is quite different in Europe. So we are not stick so much in electricity at the moment. We are stick on gas and oil and things like that. So, but the economy point here for the economists, GDP, and when I go in the school, university, I learned that the GDP is parallel on the energy consumption. This is what we learned, and I learned in the university. Your gross domestic product is parallel to the energy consumption you use or you consume. Maybe this was right before 1990, but from 1990 to the newer days, you see the gross domestic products rising up, but our primary energy, this PE means the primary energy consumption is stable. Means we're not increasing, we're not decreasing, but our economy increasing as typically people expecting. If this is okay, question mark for our people. But this now, what we now is decided in Germany is that we would like to, of course, we would like to increase the GDP of 26% to 2020, but the primary energy should be go down over 20%, and I call this is my expression, decoupling, hyper decoupling of between economy and energy consumption. So this is, we will see if this is working, we will see. So smart buildings and smart grids, which means that I wrote a book about in one month. This book will be published in English also. And this book is describing smart cities, smart buildings. My friend helped me to translate that. It was a hard work for him the last months to translate this book from German. It's a German book in English. So what means that? Decentralized of energy supply means in the past we had huge big power stations, nuclear power stations, coal power stations, and so on. We learned that these power stations are not flexible. They are not can follow the demand of the people, and that they not are able to fit as much as possible renewable in the grid. So this was the reason that we are looking more on so-called smaller, more flexible, smaller flexible units, who could do it this way that you see here the buildings, the smart buildings is part of the whole grid, so the building is also export energy. We call the building as a power plant. The building producing more as it uses it to a certain time, and sometimes he import it. And this is, let's say, the general idea. We have the mobility. Here is the e-cars. Till 2020, Germany will have 1 million e-cars on the street. I have one. You will see that. Since 3-4 years, I have an e-car. It's maybe not a car for here. Yeah, it's a small Fiat 500. Maybe you know Fiat 500. A very nice car. You can give him a kiss. You say a mooch car. Mooch car means if you give a kiss, then it's a mooching car. Because this is a car where you really enjoy it. You found everywhere a parking lot and so on. You will see that. So and the car and the buildings and the decentralized system is one unit. So they communicate with each other. When we're speaking about smart grid, what we mean is that we have an internet, an intelligent network, and we combine with this intelligent energy producing and energy consuming and producing. It's a kind of communication system. And this is, we're working on. So I would like to show you some of this project overhead. What means net surplus energy? There are two explanations. One thing is that over the year, the balance, what the building producing is higher than what the building need for everything, by the way. Not only for cooling, not only for all your fridge, all your washing machine, all your dryer is included in the balance. And this is what you consume. It means the way from energy consuming buildings to a generating building. And another but more higher, let's say, explanation is that during the lifetime of a building, the building would export more energy as it requested for to build the building. Everyone who built a building needs a lot of energy because you have to buy your glass, you have to buy your wood, you have to buy your furniture, you have to buy everything. And in our case, we do, by the way, we do a lot of concrete. Our houses is a lot of concrete. Yeah, they are not shaking when the wind coming. They're very stable. And so there is a lot of energy in the concrete and a lot of energy in the glazing because we work with nearly double or triple glazing. So and then when this is happening, this is the graph you see. This is the energy maybe you call it English gray energy, I don't know, or embedded energy, or I don't know how is the right explanation. Or gray energy is the energy who is in the material. You have to produce the material. It's called embedded energy. And during time, if this is an export building, surplus energy building, you have a certain energy payback time. As we have in the economy, a money payback time. I come to this energy payback, money payback time. When I speak about PV, it's less than 10 years, by the way. The energy payback time of this house, I will explain more of this house, is nearly 22, 23 years. And this is marvelous. Never other building will give something back. Yeah? This building, maybe this building gives nothing back. This building has only cost a lot of energy, but it gives nothing back. Right? So this is normal. Of course, this is normal. But this is, when we're speaking, let's say this was the revolution of PV. So PV is to producing from the solar the electricity. And from engineering point of view, I can tell you can sleep well, you have no problem with steam, you have no corrosion, you have no explosion, because this water sometimes when the store is too hot and the corrosion, the pump is not running by electricity, nothing happened. You can, the electricity today. What was today? It was totally cloudy, it was shit weather, it was raining. When you come to Mr. Arafat's house, still by rain we have electricity on our output of the PV. You could not believe it. But we have so much energy that you can totally light your house. By this weather today it was raining. And so this is the typically PV, so this is what is the reason that it comes so down in the economy. Solar thermal in the last, let's say, 20 years, only a factor of 2 reduction in cost. Photovoltaic comes down a factor of 8. Nowadays, factor of 10. Because also the price in the last, every month, we get new prices from the modules itself. I would like to show you, because I detained a little bit to show you some commercial buildings, what we have built in this concept. When we're doing a concept, by the way, Mr. Arafat told you that first you have to look on the location, and also when we build commercial buildings, we look on the location. What is happening on location? Is there groundwater? Is there wind? Is there how the sun is coming through the building? This is, we call it an energy concept process is on location. This is, by the way, the European Central Bank, what we are actually now building, this European Center in Frankfurt. And this building, before we started with the building, we looked, there's the Main River, the River Main in Frankfurt. And so we say, okay, why we use not the Main River for cooling a little bit? for this building. And also we're looking. There was some acoustic problems because there is a railway lane or something close. So the location is very important. Then much what I learned in my life as practical engineer, during the construction, you can make a nice design. You make a lot of simulation. I know that the scientists like to simulate everything. Yeah? Everything simulation, simulation, simulation. But what I learned after these 40 years, okay, you can simulate nice, but the only thing that's important is to make the quality of the construction. During the building is built, you have to every day on your site, and you check what all these guys doing on your construction. Otherwise, the quality will not happen. And this is what I mean with the construction organization: quality control, quality control, quality control. Because this is lessons learned from the practice, and what we also learned is when the building is finished, here you call it commissioning. I think here you call it commissioning. But the commissioning is only you look if the guys have delivered what you have ordered. But believe me, also when we in Germany, when we build buildings, there is no building who is functioning. Maybe now I destroy your thinking on German engineers. There's no building who is functioning according to your design. Never. Show me. And there's also, I'm 100% not here. I'm 100% also not in your country that the building is functioning. What I mean is, you order a green building in something, let's say, with certain values, and then the building is finished, and the building will operate totally different as you simulate, totally different as you maybe thought as engineer, as you design, the calculation. It functioned. It's functioned. Of course, it will be warm, it will be cold, it will be light on or off, but it will be not function. Maybe, as you said, you would like have a very efficient and very low-cost building. Believe me, this is in every country the same. What means we need 1 year to adjust the building, because it's not by the car. The cars built, millions of cars have built according to the same procedure. But every building we build, right? Every building is a new design, and every building we have different problems and different engineers and so on. And so this is what I would like. I mean, not in small houses like maybe residential houses. This is not so challenging. But I think on houses like this one here, they are really a challenge. Universities and so on. Yeah. See, when I stay here, I hear the noise. You hear the noise?
Yeah, the area.
See? And when I do a contract, and this I with the builder, or no, I said the owner, they give me a task. Oh, what should be the noise maximum on my desk? And then they measure it. And if this noise is not, and this is too much, this noise. You hear that? And also what I miss in this room, you know what I miss in this room? You know what I miss in this room?
Sunlight.
Huh?
Sunlight?
Windows. Absolutely.
Windows, sunlight, yeah, natural light.
You know, when I give lessons, and I'm very fine that you're not asleep yet. But the most of the people sleeping when there is no contact to outside. You need outside view, and I find in so many conferences where we go in the holiday inns and all in sitting in the cellar, yeah? Sitting in the cellar, there is the conference rooms in all the cellars, yeah? My goodness, I hate these rooms because you get boring. So I need view, I need windows, I need to see if it's snowing outside, if it's windy or whatever. So this is, sorry, this was some, but it's much important, by the way, as kilowatt hours. It's much important as kilowatt hours. How do people feel? I would like, go ahead now and show. Yeah, this is some of the buildings I designed and I maybe built. This is but this company producing photovoltaics and photovoltaic modules, and so we design. You see the photovoltaic. You see not direct the photovoltaics here on the rim and going around, but you maybe you not see it. This is also important that we make design. We are not off. You know, sometimes I see roofs where the collectors is like look. Have you seen that? This gives pain in my eyes. Because it looks like, you know, it's not really creative, yeah? The collectors have to be part of the envelope, not only boop, yeah? here in your house, I see that. Yeah? Your absorbers here on the pool look like it's not integrated. It's only edge on the roof. So architecture have to be the task to integrate that. And here this goes here. You see that this house have a kind of a dynamic. Yeah? It have a kind of power. It's not only rectangular. So, and I would not like, there's a lot of information about engineering things, but I would not like to go because I see the audience is maybe not so deep in PCMs and things like that. So, but what we're doing in such a building is we start with the envelope. You see back, this is the envelope, and very important is the glazing, of course. Nowadays we have glazing. This is schizophrenic. Normally schizophrenic. This is the right word. You keep the energy out and let daylight in. This is normally from a physical point of view schizophrenic. But they develop coatings who let's say 60%, 70% of the daylight in, we have good daylight in, and only 30% of the energy. This is you know these all sun glazing things, the dark buildings, blue and black and I don't know, bronze. This is crazy because otherwise you need again your light, right? Yeah, when you have these dark buildings, you need light. But what is theoretically right is you have windows like this one, large windows, but the glazing is reducing the energy who comes in, but the daylight will be transported. But this is a question of how to coat the so-called clear sun protection paint. And then of course shading devices and so on. This is also in this facade we insert the heating device in the facade. So the prefabrication of the facade was, by the way, wood. A very solid construction, and the envelope was wood, and this is very good insulation of triple glazing facade. Another building is this. This is a academy. This is from SMA. Yeah, it's a company who producing the inverters for the solar energy who comes from the modules is DC, the direct current, and you need to AC, and this is the company who makes 40% of the inverters of the world. They build a building for the academy, let's say for a company academy. And so you see the owner, of course, we do the whole envelope, and this is integration. Integration in the envelope, so the envelope itself is the energy membrane. And yeah, I like to explain, you see there is a lot of battery things like lead batteries and so on, and cogeneration, but this is, for us, this is basics. And for me it's interesting that you see from the architecture point and from the energy point of view, it's not a battery, it's a things who going together. So this is the facade. Also the facade gives you, let's say, tension, gives you feeling, gives you atmosphere. So we insert in the facade. This is, by the way, this is this 200 kilowatt battery for the night. And the next I would like to show you some residential buildings. This is my own one, and I'm in favor of clear architecture. Bright architect, bright means a lot of daylight. When I come in some houses, I see all these dark colors and all this dark furniture. I get a little bit
Crazy.
I'm not crazy, but it's not my feeling. I need white and light, sun and light. Of course, to protect from sun. And you see also here we have totally south. This is south facade, and also in Germany we have 30-35 degrees centigrade temperature outside. And if the sun is shining, the sun is not. He has not more power like in our city. Power. When the sun is shining, then it's shining. It's shining not so often. But 35 degrees outside and full sun off this facade is also a challenge, of course. And in our case, by the way, the sun is 60 degrees, 60 in south, highest. And in your, I think in Florida it's maybe 80 degrees, right? Yeah, 80? Which one? No, go 29. And this is 0, and this is 90, and I think in Florida the highest in summer is maybe 80 or something like that. Well, here the profession of solar or in architecture. I mean, Germany 60. I know 100%, and in winter is 15. 15 in winter and 60 in the high summer. And here I think the sun must be in summer here above you. Otherwise, it's not. I'm under belief more on. What is the latitude here? 29 is the latitude. So then it's 70, 75 nearly. So this means your sun is more over your head as on the facade. So I have no problem with glazes, by the way. So, okay, coming back, you see, this is a fully integrated system with this house producing 80% more energy as it needs for the whole running, including the car. This is a small car, okay. But for this whole energy, you're going to be producing 80% more, means 1.8 more as it consumed for everything. In the weather of Germany, means Stuttgart have 1.8 less solar as Panama City. You have 1.8, you have 80% more sun as we have. You have 1,000 kilowatt hour per square meter, and here on the horizontal, and you have 1,800. Okay. My idea was an architecture like Bauhaus. I'm a fan of the Bauhaus style, very simple, and you see the kitchen and all the things are closing to south, and the north are the bedroom and all the other serving rooms. So the house, by the way, following the hill, this is a most small hill, and you entering the house by the garage and going up, and then you'll be here in the children. The children are in the lower level, they can go in the garden, and the parents are here in the upper part of the building. This is the house from the side. You see that it's very solid, concrete, and outside we have 15 centimeter of insulation and a plaster. And this is very important that this house is solid because it's so stable. But what this young guy tried to do with PCM to increase the storage capacity of the building, this is happened when you build with concrete slabs your house, then you have a mass inside, and this house is so stable in summer. Very, very nice temperature inside, and it's very stable. Okay, there's a lot of things I would not like to bore you with heat pumps and photovoltaic and energy storage. There's a battery system inside, but you will see something. So this is a small car. At first I had a Smarty, and the Smarty was also an electric car. And then after I changed in this Fiat 859. So see, this is what I speak about. I like light. I like white colors, and I like very, let's say, how do you say? Lines?
Open space, clear space?
Clear space, yeah, maybe clear space. This is the living space, wooden, and you see for the architects, yeah? For the architects, see there is no, the floor going in the glass, there is no beam here. There's no beam, so the floor is going in the glass. The things, there is no beam, there is a beam, but the beam is, yeah, and you see also here on the top, there is no beam here. And this is, yeah, there's a lot of detail from the architecture point of view.
What's the beam?
Huh?
What's the beam?
The 2 point, it's in meters, sorry, it's 2.8, 2.87, 2.86, yeah. 2.8, something like that. Okay. Yeah, this is on the night, so also from the north side, this is the north side. You see, I'm not problem with big windows, yeah? Also, please, yeah, you always can interrupt me, by the way. You always could interrupt me.
It's okay to ask.
No problem, I like that, because I would like to come in conversation with you.
This is not a question about architecture or anything, because I don't know that, but you keep talking about how good it makes you feel.
Yeah.
To be with the light and all.
Yeah.
And like you might have been talking about it makes you feel depressed if you don't like sad. If you're in the dark.
If you know, in winter or now today in Florida, if you have not enough light in, I would not like to stay in the home because I don't like these dark rooms.
But a variation of that about being healthy.
Yeah.
It may be common knowledge and I just don't know. In natural sunlight, you can absorb your vitamin D.
Yes.
Can you absorb vitamin D through your window?
No.
No?
No, because the glazing have the physical thing of glazing is that avoid nearly 100% of ultraviolet. And this is, you have no chance to make it, to get brown behind the glazing. Also not a single glazing. Don't sit behind a single glazing and hope to get brown. Because the glazing will absorb all the ultraviolet wavelengths.
Not that. It's vitamin D that you absorb through your skin to have the vitamins to make you healthy.
Yeah, no, but you need a certain amount of ultra, I think UVB or UVD, I'm not so familiar with. Is this UVB? There's ultraviolet also distinguished between A, B, C, and I think B is for the...
Ultraviolet light.
You're saying.
Huh? B? Is it B?
You need the UV light to produce the vitamin D in your body.
Yeah, but
The glazing.
behind the glazing, you're not able to get... Okay, fine. Then this is the energy concept. The energy concept of this building is we have this big, huge photovoltaic in the roof integrated. The main thing is the chiller or the heating is the same. The heat pump and the chiller is the same. In your case, we call it heat pump. You call it chiller. Yeah, it's the same thermodynamic unit. And then the main thing is that we're using. Mr. Arafat told that we're using the soil. Here, I think you can using the groundwater. And then there is a battery. This is storage here, and the battery is here. We will see the pictures. It's an 8 kilowatt battery, and the electricity comes from the roof. Is first feed in the house, and if the house have not need enough, then we feed it in the grid, or we feed it in the battery. There are several ways. First is using in the house. When it's washing, and my wife, I told her you should wash during the day, or you should use all your. You can cook when you like, of course, but you should, as much as possible, use your appliances during the day, and then you keep as much as possible electricity in your house, because electricity in the house comes from my roof. It's cheaper as I buy it from the grid. It's only a question of. I mean, you have not to do it, but you can do it. Yeah? You should not change your life. But please, yeah, you can ask me.
How much cost the whole entire system has?
I will explain you. This is like, especially for here. Let's say come to the simple answer. Actually, in Florida, by this tax credit and all the things, it's 7 years payback time. Okay? I'm finished?
Well, anyway, we have a couple of microphones here, and maybe we can give the microphones to people, and now the people here, they're going to take that outside of it, because we want the people to. Okay. Are you finished, or do you still have some left? Let me kind of.
I go very quick to the other pictures, because I have schools and all these things. I have too much to tell you. Maybe I have more lessons here. This is the car, the battery, by the way. This is the batteries we have in the house. No numbers. I would like. Here, this is interesting. I make a short comparison between Stuttgart and here in Panama City. So this is investment cost. Whatever this means, I think you cannot really with this is benchmarks per kilowatt hour. But say for a single family house here in Panama City, you need 12. Now go to the US dollar. I go to US dollar. Yes, US dollar. So in single family house, you need 8 to 10 kilowatt peak. You need 32 up to 35,000 US dollar. And the payback time is 7 years. Lifetime is 25 years. How I come to the 7 years? Very simple. You have your investment cost, and then you get a tax credit from the government. This is available, and I'm not including incentives. Incentives is a kind of a luck. If you get one, or you get not one. Forget, I not calculate incentives here. But if you get incentives, you have a payback time maybe of 5 years or 6 years. But if you have no incentives and you have only your tax credit, then you have 7 years. Maybe this is now too quick, and if you would like to have more information, contact me. I will explain you in detail. it's no problem for me, okay? Okay, this is the building, the knife. This is now, we build some future buildings. I mean, single family houses is not a challenge for an engineer and not a challenge for an architect. So we're building bigger buildings, like in the city of Frankfurt. This also was a building in Frankfurt. You see totally photovoltaic in the facade, in the roof, and so on. Then we do schools. This is a school, primary school, also a plus energy primary school. You see here the integration of the PV in this back here on the back side of the building. And important, I would like to, let me take 2 minutes for the schools, because schools is so important for me and for us and for everyone. In the school, it's not important so much that the kilowatt hour, the energy is reduced by the school. It's my personal opinion. What is important for the school? First, we have to have good students, and first we have the good professors. But the other thing is we have the good spaces. And we make a lot of investigation in schools about spaces. What is the influence of spaces of student performance? It's also in the States, a lot of studies is done on the building or the roof's performance on students' performance. There's a lot of information, but not so much doing it. You see here this acoustics. How is the acoustic influence the student performance? Then we made a lot of excellent daylight, but this is now finished. Now is the okay. It's now finished. But I would like to tell you about these schools, because daylight is important for students, yeah, also for human beings. Then this is a very scientific curve of we measured the students' performance on maybe 6 gymnasium, maybe 500, 600 students totally, and we measured over 3-4 years the performance of the students under different CO2 level. You know what it means, CO2 level, carbon dioxide level, and you see that if the carbon dioxide level is less, it means 500 ppm above the ambient, we have more than 10% better students. This point, what you see, is a lot of measurements, a lot of investigations. But believe me, our politicians and all these crazy guys, they're looking for better insulation and better glazing of the schools, and when we're discussing about better acoustic and better air, or better light, this is not our task. And this here shows you this is much, much more from the society important as to the energy in school. It is important, but not the indoor, we call it indoor environment quality. Indoor environment quality is much, much more important for schools. So this is the school, and this we do a lot of this. This is very light school indoor. This is gymnastic hall. Okay, this is China, and then we believe in energy, and we believe in our vision. Thank you.
Thank you so much, Dr. Fisher. Obviously an expert in this area. I tell you what we'd like to do now. Alan's going to take that side of the room. I'm going to take this side of the room. I want to kind of go down real quickly, if you remember everybody is here. Professor Adesi is from Florence, Italy, which was just voted Condé Nast the top city in the world by Condé Nast travelers. It's a great architectural place. He's that. He is going to run our alternative energy programs at the Advanced Technology Center, that big new building that we're building. And so he's going to do that. Mr. Al-Mesri here runs the Islamic Institute, the Understanding Institute. It was his idea to bring all these people here, and we appreciate his work, and a lot of people that we had dinner with, and he did a great thing for us. Dr. Ali works at ARA in town here. Glenn McDonald runs ARA, so you can see that they're kind of a defense contractor. You can see the stuff with PCM and how the shelters in Iraq and Afghanistan, how they were using the solar energy to run air conditioning and such. And Dr. Ove, he is going to be running the American company that Dr. Fish is doing. In other words, Dr. Fish is a dean in Germany. We all know about German design and engineering, how great it is. But also there, they have to start their own private companies and he has one in Shanghai. And you can see his content here was just amazing, what he's doing. Those buildings he designed, unbelievable to me. And I'd love to be able to do some more of those things. So ask questions of anybody. He's Dr. Fish, of course, is our keynote person, but you can ask questions of anybody. Any questions at all? Al is on that side. I'll be on this side. Yes, sir. Let me get you this real quick here.
The average homeowner can't afford solar panels and much less wind energy. Statewide, there should be a better tax break. 30% is not enough. 50% is more likely, and better loan rates would be better. The oil and coal fuel industries have been getting $5 billion a year for decades. Can you imagine what that money would do for research on sustainable development and solar panels and so forth? The big culprit, of course, is Congress. They're captive to the oil and gas industry. So that's what has to be done. We've got to talk to Congress, we've got to talk to Rubico, we've got to talk to Sutherland.
He's a believer in solar energy, obviously. Anybody else? Right down here, sir. I'm going to give you this thing. You speak with that.
My question won't be political. I have a concern that we're seeing a lot of use of lithium batteries. And it's my understanding that the supplies of lithium worldwide are very limited. And as a matter of fact, there's one area in South America that's the primary where we find lithium. And are we not beginning to create another, like the Arab world has control of the oil, or are we ready to do the same thing with lithium?
Somebody want to take that up there, please, Dr. Fish? Go ahead.
No, I'm fully agree with you that this question of to store electricity by lithium ion battery, you ask for the resources and the availability of the resources, right?
I'm just saying that we're going to be using so much lithium that maybe in about 10 or 15 years, whoever controls the lithium is going to control our lives.
Yes. Yes. No, I'm fully agree with you. This is not the electricity storage on lithium ions or on lead batteries. In my house, it is lead, by the way. Lead, right? Lead batteries. There is not, let's say, a solution to solve the whole smart grid technology. Absolutely not. There's only a few percent. We're thinking on, at the moment, in the city side. I have not, next time when I come and speak about cities, and then we're thinking more on, when we call it about smart grid, we're thinking on power to gas. It means huge electrolysis to take the wind and PV on hydrogen. It's not new, but we do it now in a real scale. We're not speaking about research. We're speaking about installing in cities large electrolyzers and feed in the gas grid. Because in Germany, our cities have grid of gas, natural gas. And now we're feeding 10% of the hydrogen is feed in the grid. Yeah? And so this means, and also power to heat means we're using the overload of the PV and the wind and producing by heat pump hot water and store it in big hot water storages. So it's not only just thinking on electricity storage in such in batteries. It's also not for cars, right?
So the gas that you convert, you take the hydrogen off of the natural gas?
We're taking 5 to 10% of the hydrogen and feed in big gas pipes. So this is also a big amount. I mean, we're not looking only in one technology. We're looking, and this is a kind of a mosaic. Maybe mosaic.
Different sources.
So the gas goes into the fuel cell?
No, the gas goes in the gas. The hydrogen goes in the gas pipeline. The hydrogen is mixed in the gas pipeline because it's you have to transport this to the consumer, and the end consumer you use this gas for cogeneration, for simple cogeneration, not only for fuel cells. Because fuel cells, what this gentleman mentioned, we're speaking about maybe also 25 years about fuel cells, okay? Also SOEC. But I, as an engineer and practical guy, I not see any development in fuel cells. So I think, okay, this is nice, but a fuel cell at the moment compared to a cogeneration, normal cogeneration is factor of 3, 4 higher in the investment cost per kilowatt peak. It makes at the moment a big challenge for the fuel cell company. So it's still since 20%. So I see, so and to this revolution of PV, I mean, you have, I have an investment cost in dollar of $3,500 per kilowatt peak. 3,500 per kilowatt peak as an investment cost. Yeah? This is tremendous. It was some years ago 10,000 something.
Dr. Fish, over here. I'm an engineer. This is not a technical question. The key thing in your presentation, because we've known about the technology, as you mentioned, for years, the question is, what circumstances caused the German government to make it a national goal to reduce energy? Because that's where we, I think, are basically hung up here in the United States. We've started with such things as these credits, as the other gentleman mentioned. But can you, I know it's non-technical, but do you have a feeling for why the German government made this a national priority, and how does that apply to the United States? Thank you.
I got right to a question you asked, why the German government made this energy plan? What is the background? What is the reason? What is the reason for that? No, the reason for that is that what I showed before, that the people are thinking that we need to change our energy supply on fossil fuels or nuclear, so we have to alternative. And this is the reason that the German government says we have to have objectives, really clear objectives. And industry and utilities and all these companies, now they're shouting a lot, yeah, they are, oh, not possible, and so on. But it's a comprehensive approach where the building industry, the transportation industry, the utilities, yeah, we have 4 big utilities. Now they have to sit together, and we have to, I think it's a good advantage for us because we're going ahead in our technology. Yeah? We're going ahead in small gas turbines. I mean, small means some megawatt. Small means not micro turbines. And also we're going in smart grid technology. And the reason is, I think the reason is that they understand that we need a change. And maybe they also, I'm sure that our energy prices, what we will see our energy prices, let's say in the next, let's say 20 years, doesn't matter for me as an engineer, 20 years, is much, much higher as we have now, I'm sure. And this is the reason that Germans say we have no resources, we have no resources. We have no oil, we have no gas, we have coal, but coal is not more allowed to, or is not to burn only the oil. Yeah. So the reason is that we are a poor country. Yeah, we are a poor country from resources. And so when we are poor, yeah? Maybe the scientific, but I think the political parties, and this was, by the way, all parties. This was not a decision by a certain party. It was the whole parties in Germany have decided to do this energy turnaround. This was a 100% how say agreement, 100% agreement.
But I think Europe is more. I think Europe is more conscious about the climate too. They want to reduce the CO2.
Also, also the climate. But you know, when you, I mean, open spoken. At the moment, when I'm right, Germany is participating on the whole the world climate things is nearly, I think, 1.8 to 2% of the whole influence. What Germany has no influence. Germany is so small country. You heard of him? 80 million people, nothing. So we have influence of 1.8% of the world climate. Okay. So what we should do? I mean, we could make half, and then we calculate 2030, be less than 1%, much less than 1%. So because why? The other population increasing so dramatically, and we in Germany get more and more efficient. So it means in 2030 we only 1% of the whole influence of the globe. So this means what we can do is only to export our knowledge. Is the reason I established a company in Shanghai. Of course, also because I would like to make profit. I'm not a guy without.
We're not doing this for free.
But also for to export our knowledge.
Dr. Fish, I have a question for you on your home. Yes, the home that you showed us.
Yeah.
That's technically a smart home, correct?
It's 100%, let's say, one of the best from the smart philosophy. One of the best houses in the moment in Germany. Yes.
So when a main grid goes down and you have a smart home such as yours,
yeah.
How long will your home be able to sustain you without being connected to the grid? And what's the impact overall?
Okay, the building itself could retain. When the batteries are, let's say, normal filled, maybe 1.5 days. But it's not an autonomous or a self. How do you say self?
Autonomous, self-sufficient.
Building.
Okay.
This is not our goal, by the way.
Right.
But we are 1.5 day when we not have every light on, every machine, every cooking and everything is totally on. So it's maybe 1.5 day.
Well, is part of the future plan to make, I know you don't want the homes to be so much individually sustainable, but in the case of future outages, if there were like massive solar emissions or something that could cause a downage for weeks, would the plan be to make these houses where they could stand alone a little more?
I mean, this is only a question of battery. What the
Yes.
gentleman says, at the moment we have totally, we think, because we are totally 20 kilowatt hours, 24 kilowatt hours. By the LED batteries, by the way, you can only discharge them on 50%. This is the problem with LED batteries, yeah, to extend the lifetime. It's 50%, and with a lithium ion, you can have 80-85% discharge. But I'm using LED batteries because from the economic point of view, at the moment is LED cheaper for the lifetime. I mean, the whole, not only the investment cost. You're looking on the full cost. Yeah. But I'm sure that the companies in North Korea, Samsung at the moment, they do a lot of investigation on batteries. So we will see in the next 2 years, we will have some drop down the battery costs in for electricity batteries. Unbelievable.
Thank you.
Over here.
In places like Florida, there's plenty of sunshine, and you can take advantage of the PV. How about northern parts of the United States, the snow belts and above, where there is hardly any sunshine?
Yeah, this is similar like in Germany. I mean, we have what this gentleman, I think you showed about this different type of yearly solar gain. It's between, in Germany we have, I said in Stuttgart, 1,100 kilowatt hour per square meter a year on the horizontal. I think in north of America you have 1,500, so it's more or less the same. Here we have 1,800 to 1,900 maybe in this range. So it means, the energy is enough there, but the question of economy, the economy is directly related to the energy you gain from the sun. And if you have, as in Florida, 80% more sun, or let's say 60 to 80% more sun like we in Stuttgart, then if we have the same price here as we have in Stuttgart, and this is what we're working on, we recognize that here some dealers in Florida who offering the PV 50% higher than we can offer. I don't know why. I don't know why they do that. But if you're going more north, you must be cheaper and cheaper and cheaper if you would like to compete with the grid price. But here, now we are here with this price that we offer of, let's say, $3,500 to $4,000 per kilowatt peak. We are competitive to the grid, because here you pay You know, you pay for the demand, you pay for the power, yeah, and you pay this fuel, how you say, fuel assumption or something like that, huh? Fuel tax or something like that. I think you pay in average between 12 and 15 US cents per kilowatt hour total, I guess. Or you maybe you know more, and I know people pay for a private house $300 per month up to $500 per month, right? Depending on the size of the house, right? Is it in UK? Not? Is that what you pay for your house per month? Yeah? 120. Yeah, then you are excellent. Then you are an energy saver. But I mean people who speak about $400 per month. Huh? Yeah, depends on big house. This was doctors, by the way.
Yeah, in the U.S., there's always a resistance from industry. Anytime the government does try to make a change, maybe to reduce emissions or energy use, and they always cry that, you know, we're going to go broke, we can't sustain this, taxes, you'll lose your tax base. Maybe Germany, with your industry, have you seen decreases in profits? Are industry struggling with this move to renewables, or are they doing just fine? And maybe the U.S. could follow your lead if, in fact, industry isn't going broke and doing okay with this change to renewables. And my question would be, how is German industry doing? I know Stuttgart's a big business and car manufacturing area, or is industry doing fine there with this change to renewable? And maybe the U.S. could learn from that.
You have to distinguish the industry who producing this material. Let's say all this. Let's say the components you need for applied renewables. I think this industry growing well, and the other industry, okay, they are how you say, they're complaining always, but you see no influence. If you look our economy at the moment, our stock industry, stocks are rising up from the car industry. Best what you can do in the last half years, invest in stocks in Germany, because it rises up dramatically. So I not see, there is one company, the utility E.ON, is one of the 4 biggest utilities we have. They have now to change from these big units to smaller units, gas-driven power plants. They are shouting a little bit, but it's not the real. It's the same as we switch off the nuclear power stations. Everybody says we could not can switch off the power stations. We switch off immediately. 8. 8 means 8 gigawatt. Nothing's happened. The renewable energy industry was following happened in the last, look on the last 5 years. First they starting and increasing, and that comes this Chinese influence. The Chinese, we have not, I mean America is much better as Germany, you have a lot of protection. Yeah? I know it now here when we establish our company here. How many restrictions you have? How many certifications you need, how many UL certifications you need. And in Germany, you know what in Germany happened? The whole Chinese industry import the huge, the modules and all the things to Germany. Nobody asked. Huh? Nobody asked. And this means the influence of now this policy, I think there's billions of money going from Germany to China. Yeah, billions.
Because their photovoltaics are so much cheaper than the ones you can produce.
Yes. It's unbelievable. Unbelievable. I know here First Solar, they are fighting, and but I don't know, you know, this is depending on the credits that the Chinese government gives their companies. In Germany, the companies have to go to the bank and have to pay loan of 5-6%. And in China, nearly nothing.
Dr. Fisher, we have one more question. We did promise people we'd be done at 5:30, so this is the last question, but I don't know, some of the panel may be willing to stay on a little bit longer, but we do want to let everybody go after this question, and we'll do a short thank you to everybody.
Thank you. This is, I'm sort of looking at it, taking another step above from where you are, because we're going to need power plants in the future. And you're knowledgeable in all of this alternatives. My question is, what is your opinion of the geothermal as a power plant over a long period as we were using it with the nuclear? And do you think that's technically and economically feasible for long-range future? Thank you.
There is I mean, also in Germany, on certain places, the geothermal, you mean the deep geothermal, you mean the really 3,000, 4,000 meter, the dry rock projects and things like that. There is, of course, there is some existing, but the potential to contribute on the whole country is limited. So the same is, let's say, looking on the potential of biomass also. You know, there was a lot of things in Germany going on biomass. People say, oh, we would like to burn wood chips and all these things. But this is limited. The solar and the wind is not so limited, and especially solar is much more potential and I hate also these things that people take the wood and burn the wood. This is what our previous people have done, to take the wood and burn the wood. The wood, you have to, then you have, from wood you have to do electricity. This is from the thermodynamic point of view, from engineering point of view, much more clever as to burn the wood in an oven. Take the wood and produce it steam or producing and make electricity from. This all we worked so many years on gasification of wood, but also this is similar with fuel cells, not successful since yet. So there is a potential, but not the solution for the is a small part of the whole thing.
The third generation of energy is when you will be able to make fusion reactors or to control fusion process. It's down in the road, down maybe 100 years, but this is the only thing, because this is the only way you are converting mass into energy. And the converting mass into energy, just to give them an idea, if you will be able to convert 1 gram, the sun actually is a fusion reactor. If you will be able to convert 1 gram from mass into energy, you can go around, it's like $10 billion equivalent of energy based on 10 cents per kilowatt hour. Before that, we will keep struggling there and back, taxes, and so you have to select your choice, at least to live healthy and to leave something for our children.
And then some man will make a fusion bomb and we'll be right back.
Okay, we're gonna thank you so much, folks. I tell you, Gulf Coast State College is so pleased to have this panel here. So, great discussion. Specifically, Al McCain, we thank you so much for helping us. Elizabeth Hooks there did the marketing for this, had the newspaper article in there. Raise your hand, Elizabeth. And of course, Professor Adesi here, Mr. Elmeski, it was his idea at the start of this, and the Islamic Understanding Institute, which hosted this on Sunday night. Thank you so much for that, sir. Dr. Ali, who works he's a local scientist, works here at ARA. Of course, Dr. Rafa and Dr. Fisher in business together. I mean, the ideas and the knowledge here is unbelievable. Thank you so much. We really appreciate it, everybody who contributed this. Thank you, folks, for coming. We really appreciate your attendance. It was 2 hours, but a lot of good information. Thank you so much. Have a good night. Be careful on the way home.